Trigonometric Ratios, 9-6. Again, trigonometric is a fun word to say, difficult word to say as well. And this is new again for us, so some of you guys might enjoy watching this again. The three trigonometric ratios we use are sine, cosine, and tangent. Okay? Sine, cosine, and tangent. And all trigonometric ratios are used in a right triangle. So we can draw a right triangle. And when I'm on a right triangle, I always have an angle that I'm at. Okay, I consider that to be my reference point. And I put myself at that angle. I draw myself there. Okay? I'm going to call this angle A, for example, today. From that angle, okay, there's three sides of this triangle. The hypotenuse is always the hypotenuse. It doesn't change. Okay? But then from there, I've got a leg that's across from my angle. I call it the opposite leg. And then the leg that's right next to me that I'm actually touching is called my adjacent leg. Think back, we have adjacent angles, okay, they touch each other, they share a line. So adjacent leg, it touches each other, and I share this side, this line, with the angle that I'm using. Okay? The trigonometric ratios that are created then from angle A, I have sine, cosine, and tangent. They're abbreviated SIN of A. The cosine is COS, and the tangent is TAN. On your calculator, you'll see them written like that. The sine, the ratio is always the opposite over hypotenuse. So OPP over HYP is what I write. The cosine is always the adjacent over hypotenuse. And the tangent is always the opposite over adjacent. Okay, it's very important that we understand those things and we know those ratios. Okay, and to help us know those ratios, we have our friend Sohcahtoa. So we wrote this in class, Sohcahtoa. Okay, that's very important. And I write that at the top of all of my trigonometry papers that I write, that I solve. Any assignment I'm working on, I always write my friend Sohcahtoa. Okay, so let's go over a couple examples then inside of our foldable. For example 1 is just going to say write the trig ratios write trig ratios. So if I have a triangle, it's got to be a right triangle, so it makes a right angle there. This is going to be triangle DEF. Okay, and the trig ratios that I want to write, I'm going to give those in a second. Let me give you side lengths here. I've got 17 for my hypotenuse. I've got 8 over here, and then 15 on the bottom. Okay, the trig ratios I want to write are the sine of D, the cosine of D, and the tangent of D. So this is just practice writing the ratios, writing these things as a ratio. Okay? As I said, I always use my friend Sohcahtoa. So at the top, Sohcahtoa, which again, that stands for the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay? So, sine of D. Well, the sine is represented by opposite over hypotenuse, so O over H, and we're talking about angle D there, so I put myself at angle D. Okay, that's my reference angle. It's where I'm at. From angle D, the opposite side is 8, and the hypotenuse is always 17. That doesn't change. So the sine of D is 8 over 17. Cosine is represented by adjacent over hypotenuse, so A over H. My adjacent side to angle D is 15, and again my hypotenuse is 17. Tangent is represented by opposite over adjacent, so my opposite side of angle D is 8, and my adjacent side is 15. Now, one word of note here, if I'm talking about angle E, my sine, cosine, and tangent of angle E, my opposite side of angle E is now 15, and my adjacent side is 8, so it really does matter what angle you put yourself at. Okay? You cannot put yourself at angle F because angle F creates the opposite side as 17, and 17 is a hypotenuse. The hypotenuse can never be the opposite or the adjacent side. So we only do trig from either angle E or angle D. Put yourself there and write the trig ratios. Okay? The next part, example 2, uses our calculator, and it says find the value. Find the value of the following. All right, and I'm going to find the value of the sine of 56 degrees, the cosine of 10 degrees, and the tangent of 25 degrees. Now, very, very important. Anytime you use a calculator to evaluate these, which you don't know this by off the top of your head, you can't memorize this, but anytime you do this, your calculator must be in degree mode. Degree mode. Okay? If you guys use your iPhone or your cell phone, you can change it. Default is to radian. So let me take you through again. If you hit the mode button on a TI-84, there's all down the third one down is radian or degree. Default is to radian. So you have to change it to degree, hit enter, and it changes it over to there, and you can quit out of that. Now we're in degree mode. So if I want to find the sine of 56, I can simply hit the sine button and then 56. Close the parentheses because it opened the parentheses, and I get that. Let me also type in my other ones here, cosine of 10 and the tangent of 25. So I'm putting all three of those in, okay? Now, whenever we do this in the calculator, we always need to round to 4 decimal places. That will be the 10,000ths place. So 4 decimal places is necessary. You can see them there. I'm going to copy them down. Okay, so the sine of 56 was 0.8290. Cosine of 10 was 0.9848. The tangent of 25 was 0.4663. Okay, I want you to practice this sum too. Let's also find the sine of 14 degrees, the cosine of 14 degrees, and the tangent of 14 degrees, because I want you to realize those are different numbers each time. Pause the video. You evaluate this with your calculator, whatever you have. If you don't have a calculator, you can find one online, anywhere, and replay the video and find the value. Okay, you should have found the value. The sine of 14 degrees was 0.2419. Cosine of 14 was 0.9703. And the tangent of 14 was 0.2493. Okay, so trig ratios, very important that we know what they are. Use Sohcahtoa always, and then we can evaluate those in our calculator. Our next lesson, video lesson, will be going through the triangle and actually finding sides out using trigonometry.